Hi, welcome to my video on graphing a polynomial using the x and y intercepts if the curve is increasing or decreasing the intervals, and finding the maximum and minimum points and finding the concavity. So here we go. Just got one question to do because this question has a lot of information. Graph y equals x cubed minus 3x. And we're going to graph it on this grid here. And notice we have a cubic. And to start out, we want to find the x and y intercepts. So let's find the y-intercept of this cubic. So the y-intercept is when we let x equals 0. So y equals 0 cubed minus 3 times 0. So that's 0 minus 0. So we get 0. So the x and the y intercepts is 0, 0. So 1 point on the graph. So right here, 0, 0. And the second one, we want to find the x intercepts. That's when we make y equal to 0. So we have x cubed minus 3x is equal to 0. We make y equal to 0 and solve for x. So we get x is a GCF, take x out, x outside of x squared minus 3 equals 0. So x, and this is a binomial, difference of two squares, and we can say that's x and x plus minus, square root of 3 is root 3 and root 3. So that's one way to do it. We could also go x squared minus 3 equals 0, x squared equals 3, and x is equal to plus or minus the square root of 3. So we get these answers. So because we have x equals 0 here, so we have x is equal to 0, so we have a 0. When you make this equal to 0, you get a negative root 3. When you make this factor equal to 0, you get a root 3. So these are the x-intercepts. So the x-intercepts are at 0 again, which we found here. And root 3 is approximately 1.7. So root 2 is here, so 1.7 is approximately there. And a negative 1.7 is approximately there. So let's write that as root 3 and a negative root 3. So this graph will pass through root 3, 0, and a negative root 3. And because it's positive, I know right now, because that's positive, that it's going to come down through here. And I got 3 x-intercepts. There they are. So it's going to come down and bend here, come up, go through here, go up here, bend and come down. Because these are x-intercepts, that means it's going to go on through acting as a linear. So from here it comes down, bends, goes up through. So I know that's doing that. But let's do our calculus and do the derivative. So let's do y prime, which is our derivative, slope of the tangents. So the derivative here is 3x squared minus 3. So we want to find where the bending occurs, where the slope of the tangents is 0. So we let y prime equals 0. So that means we have 3x squared minus 3 equals 0. So we got 3 outside of x squared minus 1 equals 0. 3 is a common factor, we take it out. So that's 3 outside of x. It's a difference of two squares, so it's x and x. 1 and 1 plus minus. So the slope of the tangents is 0 at x is equal to negative 1 or x is equal to 1. So, but we got to find where these points are. So at negative 1 and 1, somewhere on this graph that I'm going to draw, we will have the 2 points that are going to be where the slope of the tangents are 0. In other words, the horizontal lines will go through. So let's plug in where x is negative 1. So y equals negative 1 cubed minus 3 times negative 1. So we're plugging x equals negative 1 into this cubic equation to find a point on the graph where this point is going to be maximum or minimum. We'll see in a minute. Negative 1 cubed is negative 1. Negative 3 times negative 1 is a plus 3. So that gives us 2. So this point is negative 1, 2. So the point is negative 1 right here, 2. So that point is up here. So that's the point where the curve, the horizontal line, will be tangent to it. And let's also look at the point where x is 1. So y equals 1 cubed negative 3 times 1. So 1 cubed is 1. Negative 3 times 1 is negative 3. So that gives us a negative 2. So this point is 1, negative 2. So x is 1, y is negative 2. So that point is right here. So as I said, this is positive. So the curve is coming down through here. Notice this is the lowest maximum coming up, bending. So let's see if we look at that. So let's look at, we're looking at the 2 points of, there's negative 1 and there's 1. It's 0. So we're looking at y prime now. 0 is in the middle, 2 is above, negative 2 is below. So if we take this, what we can do is make this greater than 0 and less than 0, or we can look here and just do it very quickly. Take a 2 and put a 2 here, we get a plus, and we get a plus. Put a 2 here, we get a plus. So that's 3 pluses. So that's a plus, 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 plus. Put a 0 here, positive, positive, negative. So a 0 is positive, positive, negative. So that's a negative. Put a negative 2 here, we get a plus, plus, and a plus. So that's a plus. So that means that at 1, it's going upward. At 1, it's going up like this. And from negative 1 to a 1 is negative. So it's doing this. And from a negative 1 left, it's positive. So the slope is positive. So that's a positive slope. That's a negative slope. That's a positive slope. And notice that this is positive and negative. So this is the maximum point. So this point is the maximum. And notice that this is a negative and a positive. This is a minimum point. So if we plot, this is a negative 1, 2 is max, and that's a min. So let's see if the concavity holds through. What about the second derivative? So the second derivative is 3 times 2 is 6 with an x, and the derivative of a constant is 0. So we have, if we make the double derivative equal to 0, so that means we have 6x equal to 0, x is 0. If we make, and we'll draw the double concavity, that's where it's concaving up and concaving down. So let's make 6x. The double concavity is when if we make y double prime greater than 0, we make 6x greater than 0. Divide by 6, x is greater than 0. And if we make y double prime less than 0, 6x is less than 0. Divide by 6, x is less than 0. So the concavity occurs where x is 0. So if we put x is 0 here, then on the right side it's concaved, it's positive. So on the right side it's doing, this is a 0. So let's put a 1 and a negative 1 in. So we know it's greater than 0, so we put a 1 in here, we get a 6, so that's a plus. If we put a negative 1 in here, we get negative 6, so it's a negative. So on the right side, it's positive, so it'll be doing this. And on the left side, it'll be doing this. So the right side is positive and the left side is negative, so it's opening downwards. So there it is there now. According to the slopes, it's doing this. And there it is there. That's a negative and that's a positive. And this is a negative, this is a positive. So there it is there. Negative, positive, negative, positive. So we know when we go through here, we're coming down through here, and this is a minimum point, so it turns, goes back up, it goes up through 0, and then when it gets here it bends, it comes down. So there's the graph, a cubic graph. So this is minimum point, and this is your, we call this the local max and local min. See, there's no minimum because it keeps going down forever. No maximum, keeps going up forever. So that's a minimum point, and that's a maximum point. So that's looking at all parts of that graph. First derivative, the slope of the tangents. Remember, this is a curve. The slope of the tangents here is positive. The slope of the tangents here is negative. The slope of the tangents is positive. And at this point, 0, 0, which is the inflection point, the double derivative, when x is equal to, I forgot to do that, is 0, 0. So write that in here. Just forgot to put that in. The inflection point is when f prime equals 0. Is when, so that inflection point is when 6x equals 0, x is 0. And when x is 0, you put 0 back in here, you get a 0. So the inflection point is 0, 0. Again, putting 0 back in the main equation. So I got a 0. So if I went y equals, again, I did it right here when x is 0. So I already got it done right there. So I got a 0 again. So there's 0, 0. I did it here, but I never showed you what the inflection point was. But because that's a 0, putting 0 back in, which I did here. So the x-intercepts and the y-intercept is 0, 0. So it means the inflection point came out to be the same point, 0, 0. And if you like my video, click the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.